Welcome to Makaut Smashers, and also welcome to the fascinating world of digital image processing, which is today's video topic. Have you ever wondered how pictures become clearer and more vibrant on your devices? That's the magic of digital image processing at work. It's like having a special tool that helps make pictures look better by enhancing the colors and details. From doctors analyzing medical scans to photographers editing their photos, digital image processing is used in many different fields. Together we will explore how tiny dots called pixels create images and how clever computer programs called algorithms improve them. So get ready for an exciting journey as we uncover the wonders of digital image processing and its impact on the world around us. Now, digital image processing is a field of study and practice that focuses on manipulating the digital images using computers. It involves various techniques and algorithms to enhance, analyze, interpret, and extract information from the digital images. So, we should know about some key concepts or terminologies in this subject like digital images, image enhancement, image restoration, image compression, image segmentation, feature extraction, image analysis and understanding, and machine learning in image processing. So digital image processing finds application in various fields including medicine, astronomy, remote sensing, robotics, forensic analysis and entertainment. Its continuous evolution is driven by advances in computing power, algorithms and sensor technologies, enabling the development of more sophisticated and powerful image processing techniques. At first, we should know about the fundamentals of digital images. It encompasses several key concepts that form the basic of image processing or digital image processing, we can say. At first, pixel. A pixel, short for picture element, is the smallest unit of a digital image. Each pixel represents a single point in the image and contains information about its color and intensity. Pixels are arranged in a grid pattern to form the image. Number 2, resolution. Resolution refers to the level of detail in digital image and is typically expressed in the terms of number of pixels along with the width and height of the image. High resolution images contain more pixels, thus can represent the finer details. Number 3, color models. Digital images can be represented using different color models such as RGB, red, green, blue, CMYK, cyan, magenta, yellow, black, and HSV, hue, saturation, and value. Each color model represents colors in a different way and is used for specific applications. And also number 4, bit depth. The bit depth refers to the number of bits used to represent the color of each pixel in a digital image. Some common bit depths include the 8-bit, 16-bit, 24-bit. So higher bit depths allow for a greater range of colors and finer color gradients. So also the image formats. Digital images are stored in various file formats such as JPEG, PNG, GIF, TIFF. Each format uses different compression algorithms and supports different features, making them suitable for different types of images and applications. Number 6, spatial domain. So now it is time to discuss about another concept. It refers to the representation of digital image in terms of their spatial coordinate like x and y. X and y axis and pixel values. The spatial domain operations involve directly manipulating the pixels values of an image to achieve the desired effect such as enhancement or filtering. Number 7, frequency domain. The frequency domain represents the images in terms of their frequency components using techniques such as Fourier transformation. Frequency domain operations involve analyzing and manipulating the frequency content of an image, which can be useful for tasks such as image filtering and compression. Number 8, image acquisition. So understanding this fundamental concept is essential for effectively working with digital images and performing various image processing tasks such as enhancement, restoration, segmentation and analysis. So now it is time to discuss about the image acquisition part. So image acquisition is a process of capturing the digital images from the real world using the devices such as digital cameras, scanners, or sensors. It is the first step in digital image processing and plays a crucial role in determining the quality and characteristics of the images that will be processed. So at first, sensors. Digital cameras and other imaging devices use sensors to capture the light and convert it into digital signals. The most common type of sensors include the CCD, charged coupled devices, and complementary metal oxide semiconductor (CMOS) sensors. These sensors consist of an array of photosensitive elements called pixels, which record the intensity and the color of light falling on them. Number 2. Optics. Optics. The lens system of the imaging devices focus on light onto the sensor, determining the factors such as the field of view, depth of field, and optic distortion in the captured image. The quality and the characteristics of the lens can significantly impact the clarity and the sharpness of the image. Number 3. Resolution. Image resolution refers to the level of detail captured by the imaging devices and is typically specified in terms of the number of pixels in the images. Higher resolution images can contain more pixels and can represent finer details, but they also require more storage space and processing power also. Okay, so number 4, color reproduction. Digital imaging devices capture the color information using color filters and sensors that detect different wavelengths of light. The accuracy and fidelity of color reproduction depend on the factors such as sensors, color response, color calibration, and white balance setting. Okay, so exposure control. Exposure settings such as aperture, the shutter speed, and ISO sensitivity control the amount of light reaching the sensor and determine the overall brightness and the contrast of the captured image. Proper exposure control is essential for avoiding the overexposure or underexposure and achieving the desired image quality. So noise and image format is also there. So understanding this principle of image acquisition is essential for optimizing the quality of captured images and ensuring the reliable result in the digital image processing applications. It involves considerations such as choosing the appropriate imaging devices, adjusting the exposure settings, managing noises, and selecting the suitable file formats for storage and processing. So now it is time to discuss about the image enhancement. Image enhancement in digital image processing refers to a set of techniques and algorithms used to improve the visual quality of digital images for better interpretation, analysis, or display. Enhancement methods aim to highlight the important image features, remove the noise, and adjust the brightness and contrast, and improve the overall image clarity without distorting or losing important information. Okay, so some common techniques used in image enhancement. At the first is histogram equalization, contrast stretching, spatial filtering, the noise reduction, image sharpening, histogram modification, the dynamic range compression, the color correction. Okay, so these techniques can be applied individually or in combination to achieve the desired visual quality and improve the interpretability of digital images in various applications such as medical imaging, satellite imagery, surveillance, photography, and digital art. So now it is time to discuss about the another techniques called image restoration. Image restoration in digital image processing refers to the process of improving the quality of a degraded or damaged image to recover its original appearance or to enhance its interpretability. Image restoration technique aim to reverse the effects of various factors that cause the degradation, such as noise, blur, compression, artifacts, and sensor imperfections. The goal is to produce a restored image that is closely resemble the original scene or minimize the impact of degradation while preserving the importance of image features. So, noise reduction, blur removal, super resolution, image in painting, compression, artifact removal, sensor calibration, image registration. So image restoration techniques are widely used in various applications such as medical imaging, satellite imagery, surveillance, forensics, and digital photography to improve the visual quality and interpretability of digital images and enable more accurate analysis and decision making. So now it is time to discuss about the another technique called image compression. in digital image processing. It refers to the process of reducing the size of a digital image file while minimizing the loss of image quality. The primary goal of image compression is to reduce the storage requirements and transmission bandwidth, making it more efficient to store, transmit, and process digital images. So there are mainly two types of image compression: lossless compression and lossy compression. In lossless compression techniques reduce the size of an image file without any loss of image quality. In lossless compression, the original image can be perfectly reconstructed from the compressed data. So the lossy compression technique achieves higher compression ratios by discarding some image information that may not be perceived by human viewers or is considered less important. Okay. So image compression techniques are used in various applications such as digital photography, web applications, medical imaging and satellite imaging, multimedia applications, etc. So the choice of compression algorithm depends on the factors such as desired compression ratio, the acceptable level of image quality loss, the computational complexity, and specific applications requirements. Each compression algorithm has its advantages and trade-offs in terms of compression ratio, computational complexity, and image quality retention. Therefore, selecting the most appropriate compression method requires a careful consideration of these factors based on the specific needs of the applications. Okay, so now it is time to discuss about the feature extraction and image segmentation technique. These are the two main important tasks in digital image processing that play a crucial roles in various applications such as object recognition, image analysis, and computer vision. So some overview of feature extraction. It involves identifying and extracting the meaningful information or features from the digital images. These features represent the distinctive characteristic of objects or patterns present in the images and are used for tasks such as image classification, object detection, and image retrieval. Feature extraction can be performed in both spatial and frequency domains and typically involve the following steps like pre-processing, feature detection, feature description, feature selection. Okay, so some examples of feature extraction technique include the histogram of oriented gradients or HOG for object detection, speeded up robust features SURF for image matching, and convolution neural network for learning the hierarchical features from image data. You can see this topic in our computer vision videos. Okay, so now image segmentation. The image segmentation is the process of partitioning an image into multiple regions or segments based on certain criteria such as color, intensity, texture, or edge information. The goal of segmentation is to group together pixels that belong to the same object or region while separating them from pixels belonging to different objects or background. Image segmentation is typically performed using the following method like thresholding, region growing, edge-based segmentation, clustering, watershed transformation. Okay, so image segmentation is a fundamental step in many image processing and computer vision applications including object recognition, image-based measurement, medical image analysis, and scene understanding. So in summary, feature extraction and image segmentation are essential techniques in DIP or digital image processing that enable the extraction of meaningful information from images. Okay, so now it is time to discuss about the application of digital image processing. So digital image processing finds application across the various domains due to its ability to analyze, interpret, and manipulate the digital images. At first, biometric and security. Digital image processing is extensively used in biometric systems for identity verification and security application. Biometric modalities such as fingerprint recognition, iris recognition, face recognition, and voice recognition rely on image processing algorithms to extract the distinctive features from the biometric samples and match them against the stored templates. Image processing techniques help in pre-processing the biometric images, enhancing the feature visibility, and improve the recognition accuracy in various security applications including the access control, border security, forensic analysis, and surveillance. And other is like remote sensing and medical imaging. Okay, so now as we come to end our journey of exploring the wonders of digital image processing, I hope as you have gained the valuable insights into this fascinating world of pixels and algorithms. If you have enjoyed this adventure and learned something new, don't forget to hit the like button and below to let us know. Share this video with your friends, family to learn from experience and gather the knowledge from these videos. And also remember to subscribe our channel for more captivating content on technology and innovation. Your support keep us motivated to bring you engaging and informative videos. Thank you for joining us on this exciting exploration, and until next time, keep exploring and keep learning.